Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, let me introduce myself. My name is Lerian Edward. You can call me Sally. I'm studying at the University of Padang. Now, I will to tell you about Newton's law of motion. Enjoy watching! Sir Isaac Newton's law of motion explained the relationship between a physical object and the forces acting upon it. Understanding this information provides us with the basis of the modern physics. What are Newton's laws of motion? First, an object at rest remains at rest and an object in motion remains in motion at a constant speed and in straight and unless acted on by unbalanced force. The second, the acceleration of an object depends on the mass of the object and amount of force applied. And third, whenever one object exerts a force on another object, the second object exerts an equal and opposite on the force. Sir Isaac Newton worked in many areas of the mathematics and the physics. He developed the theories of the gravitation in 1666 when he was only 23 years old. In 1686, he presented his three laws of motion in the Principia Mathematica Philosophiae Naturalis. By developing his three laws of motion, Newton revolutionized science. Newton laws together with Kepler laws explained why planets move in elliptical orbit rather than in circle. Newton's first law of inertia. An object at rest remains at rest and an object in motion remains in the motions at constant speed and the stagnant unless acted on by unbalanced force. Newton's first law states that every object will remain at rest or uniform motion in the stagnant unless compelled to change its state by the action of the external force. This tendency to resist change in the state of motion is inertia. If all the external force cancel each other out, then there is no net force acting on the object. If there is no net force acting on the object, then the object will maintain a constant velocity. If the velocity is zero, then the object remains at rest. If an external force acts on the object, the velocity will change because of the force. Example of inertia involving aerodynamics. 1. The motion of an airplane when a pilot changes the throttle settings of the engines. 2. The motion of a ball falling down through the atmosphere. And 3. A motor rocket being launched up into the atmosphere. And 4. The motion of kite when the wind changes. Newton's second law. Force. The acceleration of an object depends on the mass of the object and the amount force applied. His second law defines a force to be equal to change in the momentum or mass times velocity per change in time. Momentum is defined to be the mass of an object times its velocity or v. Let us assume that we have an airplane at a point 0 defined by its location x0 and time 0. The airplane hits mass 0 and the travel at velocity 0, and the external force F2 the airplane shown above moved at a point 1. The airplane now location in the x1 and time t1. The mass and the velocity of the airplane change during the flight to values m1 and v1. Newton's second law can help us determine the new values of the v1 and m1. If we know how big the force F is, let us just take the difference between the condition at the point 1 and the condition at the point 0. Newton's second law talk about change in the momentum. So at this point, we can separate out how much the mass changes and how much the velocity changes. We only know how much product changes. Let us assume that may stay at a constant value equal to m. This assumption is rather good for an airplane because the only change in the mass would be for the fuel burned between 0.1 and 0.0. The weight of the fuel is probably small relative to the weight of the rest of the airplane, especially if we only look at small changes in time. If we were discussing the flight of baseball, then certainly the mass remains a constant. But if we were discussing the flight of the bottle rocket, then the mass does not remain a constant and we can only look at changes in momentum. For a constant mass, Newton's second law looks like F equal m times in mid V1 minus V0 for mid T1 minus T0. This change in velocity divided by the change in the time is the definition of the acceleration, or A. The second law reduced to the more familiar product of mass and acceleration. F equals m times in mid A. Remember that this relation is only good for objects that have a constant mass. This equation tells us that an object subjected to an external force will accelerate and that the amount of the acceleration is proportional on the size of the force. The amount of acceleration is also inversely proportional to mass of the object. For equal force, a fair object will experience less acceleration than a lighter object. Considering the momentum equation of force causes a change in velocity, and likewise a change in the velocity generates a force. The equation works both ways. The velocity, force, acceleration, and momentum have both a magnet and direction associated with them. Scientists and the mathematicians call this a vector quantity. The equations shown here are actually vector equations and can be applied in each of the competent directions. We have only looked at one direction, and in general an object moves in all three directions: up, down, left, right, forward, back. Example of force involving aerodynamics and aircraft motion resulting from aerodynamics force, aircraft weight, and thrust. Newton's third law: action and reactions. Whenever one object exerts a force on the second object exerts an equal and opposite force on the first. His third law states that for every action or force in nature there is an equal and opposite reactions. If object A exerts a force on the object B also exerts an equal and opposite force on the object A. In other words, force results from interactions. Example of action and reaction involving aerodynamics. 1. The motion of lift from airfoil. The air is deflected downward by the airfoil's action, and in reactions, the wing is pushed upward. 2. The motion of spinning ball. The air is deflected to one side, and the ball reacts by moving in the opposite. 3. The motion of a jet engine produces thrust, and the hot exhaust gases flow out the back of the engines, and the thrusting force is produced in the opposite direction. So that's all for me. If you found many mistakes in my presentation, please forgive me. Thank you for attention. The last I say, wassalamualaikum warahmatullahi wabarakatuh. Bye bye.